Before going through our topic today, I would like to remind you for something I covered last meeting, because this part will be included in the first exam of this course. Let's do an example. We have a swimming pool. Looks like this. This is swimming pool with water surface like this, and the height for this part is 5 feet. The height of this part is 10 feet, and yeah, that's enough. We have wall A, B, C, D, E, F. I'm drawing cross section in a swimming pool with the given dimensions, and this lenses, these lenses equal 10 feet, 5 feet, and 5 feet. What is the water pressure on wall AB? Do you remember the water pressure? P equal gamma H. Gamma, unit weight of water, equal 9,810 Newton per cubic meter, or 62.4 pound per cubic feet. H is the vertical distance or vertical height between the point and the water surface. So if you are looking for pressure on wall AB, here is wall AB, point A and point B. What is the pressure at point A? What is the pressure at point B? Pressure at point A equal gamma H, because you are talking about feet. So gamma water in this problem will be 62.4 pound per cubic feet. I'm talking about this wall, wall AB. Pressure at point A equal gamma 62.4 times H. What is the H value for point A? Do you have a distance between point A? Do you have a vertical distance between point A and the water surface? No. Your pressure equals 0. Pressure at point B equal gamma 62.4 times H. Do you have a vertical distance between point B and the water surface? Yes, we have. What is the vertical distance? 10. So the pressure value will be 624. So we don't have value here. We have a value here. This value is perpendicular to the wall surface. How much? 624. If you connect between the two values, that means we have pressure looks like triangle, like this. If you would like to get the equivalent force for this pressure, this equivalent force F equal the area of this triangle, 1/2 times 10 times 624. You can get the equivalent force for this pressure equal 0.5 times 10 times 624. equal 3,120 pound. What is the pressure on wall FE or EF? Wall EF. Here is the pressure, here is the wall EF. We are looking for pressure at point F, pressure at point E. Gamma H 62.4. What is the vertical distance between point F and the water surface? I believe we don't have vertical distance, so your pressure equals 0. For point E, 62.4, the gamma water. What is the H? For point E, vertical distance between point E and the water surface is 5. This pressure will be 312. So we don't have pressure here. We have pressure here, 312. If you connect between the two values, you can get a triangle. The equivalent force for this triangle equal 1/2 times 5 times 312, which is the area of the triangle. This value will be 780 pounds. If you are looking for what is the pressure on the inclined surface, CD, for surface CD, here is C, here is D. So what is the pressure at point C? What is the pressure at point D? Gamma H 62.4 is the value of gamma. What is the value of H for point C? Guys, here is point C. The H value is the vertical distance between point C and the water surface. What is the value of this H? Equal 10 feet. So the value will be 624. Pressure at point D equal gamma times H. What is the H value for point D? Here is point D. What is the H value? The vertical distance between point D and water surface. This value equal 5. So your pressure equals 312. So be careful. The value at point C is perpendicular to the surface, 624. The value at point D is perpendicular to the surface, 312. If you connect between both of them, you can get this shape as trapezoid. So this shape represents the water pressure on this surface. The water pressure on this surface for this swimming pool. If you would like to get the equivalent forces, okay, I can divide it to rectangle with equivalent force here. How much? 312 times this length, time L. And another triangle with equivalent force, how much? 1/2 times L times 312. This little distance will be 312. So I converted the water pressure to two equivalent force, F1 and F2. Any question for this point? Any question for any application related to water pressure, which equal to gamma H?
For CD,
Yes.
is the length, do we use 5 or we need to solve for the length also?
Okay, the horizontal distance for this triangle is 5. The vertical distance for this triangle is 5. 10 minus 5 will be 5. From this 5 and this 5, I can figure out the length of surface CD. probably it will be 5 square root of 2. That makes sense?
Yes, thank you.
Yeah, it's right angle triangle. CD, this distance is 5, this distance is 5, so this length will be 5 square plus 5 square, all of them under square root. Okay, what will happen if you have a curved surface? Like this? Nothing will happen, except we will have two components. The first component is a horizontal component for the pressure. The second component is a vertical component for the weight of water. I'm sorry, what you mean by weight? Okay. We have a curve like this. We have a curve like this. The first component is the vertical component. This water has weight, W. Weight of water. How can I get this weight? Okay. Gamma water equal weight divide volume. If you are looking for weight, you have to multiply gamma water time volume. If you can get the volume of the water, multiply it by gamma water to get the weight. This weight is the vertical component. What else? For this point, pressure equals 0. For this point, pressure equal gamma H. So we have pressure distribution looks like this. You can convert this triangle to a force like this. I will get the projection for this curve. Projection of this curve, we will have 2 points. The first point here and the last point here. P equal gamma H. We don't have H, so pressure equals 0 at this point. At this point, pressure equal gamma H. We have H, this H. If you multiply it by gamma, we can get a triangle like this. This triangle will give you a horizontal component force F. So the final conclusion, if you have a curve, we will have two components. The vertical one represent the weight of the water. The horizontal one represent the equivalent force for the water pressure. That's it. Nothing needed anymore for this point. The hydrostatic force on a curved surface can be analyzed best by resolving the total pressure force on the surface into horizontal and vertical component. The horizontal one coming from water pressure, the vertical one coming from the weight of the water. So the horizontal component of the total hydrostatic pressure force on any surface is always equal to the total pressure. The vertical component of the total hydrostatic pressure force on any surface is always equal to the weight of the entire water. That's it. We don't need anything more for this slide. Slide number 12, slide number 13, and slide number 14. Let's do this example. We have a curve, and we are looking to determine the total hydrostatic force on it. First of all, let's do the horizontal one. At this point and this point number B, point number A. We don't have here pressure. Pressure equal gamma H equal 0. Pressure here equal gamma H. Gamma equal 9,810. H, what is the vertical distance? 2 meters. So the pressure at the bottom of the curve will be 19,620. So the equivalent force for this pressure F horizontal equal 1/2 time the vertical distance 2 meters, and this value equal 19,620. It will be 19,620 Newton. The vertical force FV equal weight of water above the curved surface. This weight equal gamma time volume. Gamma of water 9,810. What is the volume here? What is this volume? Uh, 5 meter long, 2 meter high. So the length of this gate is 5 meter. So what is the volume? The area. Sorry. By R square. By R square time quarter time 5 meter. You can get the volume. By time 2 square time quarter time 5 time 9,810. This value will be 154,095 Newton. I understand you have a question. How can I get the volume of this curve? This curve is extended to the other side with 5 meters. If you would like to get the volume equal this area, the area of the base, time this height in the other direction. What is the area? What is the area here? So the volume equal area of base time height. This height equal 5 meters. What is the area of the base? It's the area of quarter circle. This circle with radius 2 meters. So what is the area of the circle? By R square. But this is area of a complete circle, of a whole circle. We have only quarter circle. So I will multiply it by quarter. So the volume of this gate, which is extended 5 meters in the opposite direction, the volume equal area of base, which is quarter circle, time height 5 meters. Once you get the volume, the weight equal gamma time volume. Any question for this point? So if you have a curved surface, we have two components. The first component is a horizontal one coming from the water pressure. The second component is the vertical one coming from the weight of the water. If you would like to get the weight, you have to multiply gamma by volume. Volume for anything equal area of base time height. If you have any question, let me know. Another example. We have quarter circle gate. This one. And we need to determine the total hydrostatic force on this gate. This gate is extended 5 meters long in the other direction, 5 meters. Okay, one step, the first step. Let's do the horizontal pressure. This gate will be projected like this line. We have the first point, point number 1, and the second point, point number 2. What is the pressure at point number 1? What is the pressure at point number 2? Gamma H, gamma 9810. Please be careful. If you are talking about meter, gamma water equal 9810. If you are talking about feet, gamma water equals 62.4 pound per cubic feet. This one Newton per cubic meter. Anyway, so what is the H value for point number 1? Do you have H? Do you have distance? I'm sorry. Do you have vertical distance between point 1 and the water surface? Yes, we have. How much? 10 meters. So the water pressure will be 98,100. Pressure at point number 2 equal gamma times H. What is the H? What is the vertical distance between point number 2 and the water surface? Is 13. So the water pressure at this point, 9,810 times 13, equal 127,530. So we have a value here. We have another value here. So we have this trapezoid. This value equal 98,100. This one equal 127,530. I can get the equivalent force F. This F, you can divide this shape to triangle and rectangle, whatever. I can get the final value will be 338,445 Newton. The vertical component, FV, this one is F horizontal. FV equal gamma water time volume. 9,810 time volume of this water equal to area by R square time 1/4, because we have quarter circle, time the length of this gate is 5. So I can figure out by r square times 5 equal 346,714 Newton. This is the horizontal one. I'm sorry, this is the vertical one, and this is the horizontal one. What will happen if you have tank with different liquid? Probably we have water, we have mercury, and we have oil. 3 different liquid. This one and this one and this one. What is the pressure at this point? Pressure at point A. We understand that pressure equal gamma H. Which gamma and which H? If this fluid is water, we have different gamma. If this fluid is mercury, we have different gamma. If this fluid is oil, we have different gamma. And each fluid has different H. This H, this H, and this H. So what is the pressure at point A? Gamma H. Which gamma and which H actually equals summation gamma H for any liquid above this point. So this gamma time H, this gamma time H, this gamma time H, all of them, you need to sum all of them together to get the final pressure at point A. So for example, if you have a tank like this with 2 liquid, the first one is water, the second one is oil. Gamma of water 62.4, gamma for oil equal 96. This height 4 feet, this height 5 feet. What is the pressure at point A? Pressure at point A equal summation of all gamma H above this point. So we have water 62.4 times H of water 5. We have also above point A oil 96 times height of this oil 4. I can get the pressure of this liquid on point A. 62.4 times 5, 96 times 4. The pressure will be 691 pound per square feet. If I'm looking for pressure at point B, any answer? Anybody can help me to answer what is the pressure at point B? Okay, summation of all gamma H above point B. What are the liquids above point B? What are? We have only one liquid, which is water, 62.4 times 5. I can get the pressure 312 pound per square feet. What is the pressure at point C? What is the pressure at point C? Equals summation gamma H above point C. Do you have anything above point C? No. The pressure at point C equal 0. That makes sense? So this slide is talking about the pressure at different depth in a different liquid. Pressure at the bottom equal summation gamma H. Summation of all gamma H above the required point. Guys, I have a question which is very important, and you need to understand this point. If you have a tank like this, and we have water, at this level, what is the pressure at this point? What is the pressure at this point? What is the pressure at this point? What is the value here? Point number 1, point number 2, point number 3. All of them at the same level. What is the values? What do you think? Are they equal or same values? So if we have points at the same level in the same liquid, pressure is constant. All of them has the same value of pressure, but make sure you are talking about same level and same liquid, because one of you will say, hey, what will happen if we have two tanks like this? One of them with water, one of them with oil. If I draw the same level, what is the pressure at this point? What is the pressure at this point? Point number 1 and point number 2. Do you think point number 1 and point number 2 have the same pressure? Both of them at the same level. Yeah, I agree with you, but point B1 and point 2 in different liquids. Point number 1 in a water, point number 2 in oil. So pressure at 1 equal gamma H. Pressure at 2 equal also gamma H. I agree with you that this H is the same like this H. Both of them the same because we are talking about the same level. But we have different gamma because we have different liquid. So the rule is any points at the same level in the same liquid, all of them have the same pressure. That makes sense? I think. We have an instrument called manometers. Manometers. Guys, just a second. I will drink some water. We have an instrument called manometer. This instrument is used to measure the pressure acting on a column of fluid, especially one with U-shaped tube of liquid in which a difference in the pressures acting in the two arms of the tube causes the liquid to reach different heights in the two arms. Anyway, remember, we don't have any relationship. We don't have any relationship between pressures at 2 points in different liquid. So we have this U-tube, this shape of the tube, U shape like this. What will happen if I draw this line, this horizontal line? Do you think we have a relationship between this point and this point? Do you think we have a relationship between the pressure at this point, point number 1, at point number 2? Do you think? I don't think so. Why? Because we have here a fluid, a liquid, liquid number 2, and we have here another liquid, liquid number 1. And we have 2 points. I agree with you, at the same level. Yes, that's right. But in a 2 different liquid. So I cannot say anything between point number 1 and point number 2. What will happen if you draw this line or this horizontal level? I believe I can say, hey, this point and this point at the same level. That's right. Both of them in the same liquid, liquid number 2. So I can say pressure at this point, point number 1, equal pressure at point number 2. That's right. That's right. So when you are solving any problem related to manometer, you have to draw a horizontal level passing through the same liquid. At this point, point number 1, what do you have above this point? What do you have? We have gamma 1 H1, which is this pressure. Gamma 1 times H1. What else? And we have pressure inside this bulb, so we have P naught. These two terms are the pressure above this point. What do you have on the other side? We have another pressure coming from this column, which is gamma 2 H2. Gamma for this liquid times H2. Plus, we have pressure here at this location, P2. Because we are talking about 2 points at the same level in the same liquid, both of them must be equal. One more time. One more time. We need to draw a horizontal level. This level passing through the same liquid. We can do it here, that's right. But I highly recommend to do it at this interface. This liquid is the same like this liquid. So pressure at this location equal pressure at this location. Because we have the same, we have 2 points at the same level in the same liquid. So what is the pressure above this point? We have this liquid or this height plus this pressure. So gamma 2 H2 plus P2. What is the pressure above this location? We have this liquid or this height, gamma 1 H1 plus the pressure inside this bulb. So I can equate these terms together and figure out the missing part. Let's do this example. Let's do this example. We have a mercury manometer with a specific gravity equal 13.6 is used to measure the pressure difference in vessels A and B. This pressure PA inside vessel A, we have pressure P inside vessel P, which contains water. So this liquid is water. This liquid is water. And this liquid is mercury. We need to determine what is the pressure difference between the two vessels, between A and B. First of all, anybody can tell me what is the gamma of mercury? Gamma of water equal 9,810. We know this. 9,810 gamma of water. What is the gamma of mercury? How can I get the gamma of mercury? Any answer? Any answer? How can I get the gamma of mercury? Do you think gamma of mercury equal 13.6? Or how can I get the gamma of this liquid, mercury? No answer? No answer. Looks like someone is multiplying by gamma water. Yes, Marcus, yes. What else? Guys, do you remember specific gravity? This point is very important because during the exam, probably I will not give you the gamma value, but I will give you specific gravity for a liquid. Specific gravity for any liquid equal gamma for this liquid divide gamma of water. So right now, I'm giving you the specific gravity for mercury, which is 13.6 equal gamma of mercury divide gamma of water 9,810. So if you would like to get the gamma of mercury, it will equal specific gravity time gamma water. So gamma of mercury will be 13.6 times 9,810. This value will be 133,416 Newton per cubic meter. That makes sense? So be careful about this point. Be careful about this point. The second step, what do you think? Do you think, I think we will do a horizontal level at this location. We need to go through the same liquid for mercury. So I can say pressure at this point equal pressure at this point. So what is the value of pressure at point 3, which is this one? What do you think? Equal this height of water, which is gamma water time. What is the height here? What is this height? 15 plus 12 equal 27. So 27 divide 100. 27 centimeter. We need to convert it to meter, so I divided it by 100. What else? What is the pressure at point 2? I think pressure at point 2 equal pressure at point 1 equal pressure at A. Pressure at A equal pressure at point 1 equal pressure at point 2. So plus pressure at A. Guys, pressure at point 3 equal this height of water plus pressure at point 2, which is equal pressure at point 1, which is equal pressure at point A. So pressure at point 3 equal this term. Pressure at point 3 equal gamma water 9,810 times 0.27 plus PA. Your final answer will be plus PA. What is the pressure at point 4? The other side. What do you have on the other side? We have this height, which is gamma mercury time 15 centimeter divide 100. What else? What do you have above point 4 else? We have this height of water, which is gamma water time what? 123 plus 12. So the total height here will be 135. Divide 100, because this one will be centimeter. What else? What do you have here? Pressure at B. So your final answer, gamma mercury. Do you remember what was the gamma mercury? 133,416 times 15 divide 100. This term plus gamma water time 135 divide 100. We will have this value. Plus P at B. So your final value will be 33,255.9 plus PB. What I did, I calculated the pressure above point 3 and calculated the pressure above point 4. What is the relationship between pressure at 3 and the pressure at 4? I believe P3 equal P4. P3 equal this term, pressure at 3 equal pressure at 4. So 2648.7 plus PA equal pressure at 4, which is 33,255.9 plus PB. We are looking for what is the difference between PA minus PB. So I can move this one to the other side and this one to this side. I can get the final answer equal 30,607.2, which is the difference between pressure at A and the pressure at B inside the two vessels. So just to review what we learned today, I went through the water pressure, which one? For a tank like this, or pool or swimming pool, and what is the water pressure on a curved surface. We have two components, vertical component and horizontal component. And we learned if you have multiple liquid and you are looking for pressure at a point, so the pressure equals summation of gamma of H above this point. And we learned what is the meaning of manometer. How can we solve a problem of manometer? You have to draw a horizontal level passing through the same liquid to say, hey, we have 2 points at the same elevation in the same liquid. The pressure at the 2 points are equal. Pressure at this point, for example, equal everything above this point. Pressure at the other point equal everything above this point. The two pressures are equal. And we solved this example. We have another instrument called a barometer, another device that works on the same principle as the manometer. Just for your information, we have piezometer also to measure with the water pressure inside a pipe. We stopped here at buoyancy. I will cover it next week. What is the meaning of buoyancy? By the way, for homework number 2, you need to solve question number 1, question number 2, question number 3, question number 4. You don't need to solve question number 5 and 6. We didn't cover yet. Not yet.